Write down today some terms that we're going to use as we move through this chapter. So the first thing I'm talking about is the point estimate. A point estimate is the value of a statistic that estimates the value of a parameter. Where does a statistic come from? A sample. Where does a parameter come from?
Population.
Population. So I'm just saying I'm going to use a point estimate to estimate something from an entire population. If I wanted to know how many students in our high school ate breakfast each day. And so I took a survey in this classroom and I found that 10 out of 15 of you had breakfast. Then if I'm trying to use that to estimate how many students in the whole high school ate breakfast, that would be using my point estimate to make some guess about my parameter. Now we have been finding these point estimates already. That was our p hat. And we know from chapter 8, you find p hat by doing x over n. So the difference is, in this section we are going to talk about taking that number from my sample and how to expand that to use it to make some kind of guess about my population. Because I know even if 70% of you guys had breakfast, is it likely that exactly 70% of the whole high school had breakfast today? No. So we have to have some way of making some kind of guess about that. Alright, so here's our first example. So we have a poll that asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a point estimate for the proportion of registered voters nationwide who are in favor. So how would I do that?
1,723 divided by 1,780.
Okay, so that is 0.6298. So we could say about 63% of the voters favored the death penalty here. So that's what I found for my sample. Here is my next question for you. Does this mean that most people favor the death penalty? They did in my sample. Does that mean that overall most people do? No. We can't really jump to that assumption. We found that in our sample, but we can't guarantee that for the entire population. If I had a different sample, would I likely get a different percentage? Yeah. So one question we'll be talking about is how confident are you in this estimate? We are going to be building confidence intervals in this section. And we'll be able to say, I am 90% confident that the value falls between this number and this number. So let's just say due to the variability in the samples. We need a range of values. We can't say it is this number, but I could probably get it falls between this number and this number. And with that, we have to include the likelihood the interval contains the unknown proportion. Nothing is ever guaranteed. I will never be able to say with 100% certainty it falls between 40 and 60%. We aren't going to be able to do that. But I might be able to say, okay, I am 95% confident it falls between 55 and 65%. So we will give a range of values, and with that we will have our confidence interval, with our confidence level, how confident we are. So, couple terms here. The confidence interval and level of confidence, those are two things that we will be using for the rest of the section to help answer these types of questions. So when I'm asking you to build that confidence interval, I'm asking for the range of values. Your point estimate will have to fall in there. So we got a point estimate of 0.6296 or something. So when I'm building my confidence intervals, 0.62 would have to fall in that range. And then the level of confidence is how sure we are accurate. Level of confidence will always be a percent. We'll use like the alpha notation with that we've seen before in chapter 7 where we were talking about normal curves. So that is still true. So just kind of a recap again, you don't need to write this down because we have it. We know that when we are looking at this, your mean is just your p, your proportion, your standard deviation that we've seen before was the square root of p times our 1 minus p over n. So that part is what we were using in the last bit. So let's talk about the new piece here. We're really going to be making these confidence intervals. So to do that, we have a formula. This is on your formula sheet. If you look at chapter 9, the very first bullet there has what I'm getting ready to put down on our next slide. So it will give us our confidence interval. So it's 1 minus alpha times 100%. It's just going to say like build a 90% confidence interval or a 95% confidence interval, something along those lines. And what it means, it's going to be found by taking your point estimate and adding and subtracting an amount. That amount is what's called the margin of error in this. Okay. In other words, in interpretation, if I said a 95% level of confidence, that would mean that if I made 100 different confidence intervals, 95 of them would include our given value, 5 would not. Okay, so it's kind of telling you, if I repeated this over and over again, how many times would the true value fall in my interval? It would be there 95 times out of 100. So we'll do this by our point estimate plus and minus the margin of error, which is what was given on your formula sheet. We have to meet all the requirements for p hat that we've had before. So when we make this confidence interval, we will find the upper and the lower bound. On your formula sheet, it has the plus and minus, but we'll get both of those. Your proportion minus z alpha over 2, I'll talk about that more in a second when we do an example, times, this is just our standard deviation. So it's basically your mean minus something times your standard deviation and your mean plus something times your standard deviation. We still have to have the same requirements for our p hat. So the n times p times 1 minus p has to be bigger than 10. The n has to be less than 5% of the whole population. So all the stuff from 8.2 is still true. we're just adding to it. The thing that you're adding or subtracting sometimes is referred to as your margin of error, so you might want to just jot that down. Margin of error is the thing you're adding or subtracting to your confidence interval, or sorry, to your proportion. Margin of error is impacted by a few different things. As the confidence level increases, so does the margin of error. You know, if you think about, if this is your guess, okay, here would be one confidence level, but if I want to be more confident in that answer, what would I have to do with that interval? Yeah, so if you want to be more accurate, if you want to have a higher confidence level, you will have to make your margin of error larger. A wider interval. Second thing that will impact it is sample size. We know that in general, the larger our sample, the more accurate our information is. If I just ask you guys who ate breakfast, that's probably not as accurate if I ask the entire hallway. You know, the more people you have in the sample, the more accurate it is. So as sample size increases, the margin of error would decrease. The more people I have, the less error will be involved in my sample. Last thing, we know that in general, standard deviation is how spread out it is. So a larger standard deviation means you have a larger margin of error. We know really small standard deviation means all of our values were very close to one another, so you would get a small error in that situation. When my data is really spread out, there's a lot more error involved. So those are some things that can impact our confidence levels and our margins of errors when we're looking at how many people we sampled, what the standard deviation was, how confident do we need to be in our answer. All right. Let's actually do some examples. So let's go back to the example that we used earlier. I want to go ahead and build a 90% confidence interval for this. So a few things you have to do. Step one, you need to get your point estimate. So we already did this once. Our p hat was our x over n. We got 0.6298. I'll put a couple more decimal places. 37. Second thing, just like in section 8.2, anytime I'm doing these p-hat examples, you need to check your criteria. That means your n times p times 1 minus p has to be greater than 10, and this has to be less than 5% of the population. So 1,783, would that be less than 5% of all registered voters? Okay. So that one's good. My n times p times 1 minus p. greater than or equal to 10. So my N, our P, and that comes out to be 415.69, so we're good there. Next, we need to find this Z alpha over 2. Okay, when I say a 90% confidence interval, what that means is I need 90% of my values to fall in the middle. Okay, so how much is left for each end then? 5%, right? There's 10% left over. If you split it up in the two ends, each of these is 5%. So we usually always just go with this upper number. We're trying to find the Z that matches that. So what we're going to do is look in our table. We need our probability to equal 0.95. If I only want 5% above that, I'm looking on the inside of my table to find when my probability is 0.95. And that's the one that falls exactly in between the 0.9495 and the 0.9505. So what is my Z value? 1.645, right, because it falls in between 1.64 and 1.65. Now we can make our confidence interval. So our lower is your point estimate minus your Z alpha times your standard deviation. So your P, 1 minus P over N. I get 0.6111. What changes for the upper? Yeah, can I just put a plus and not rewrite all this? Do you guys know what I'm doing? If you just hit second enter, you can bring it back up in your calculator and just change your minus to a plus. Okay. So what this means, if I asked you to write a sentence describing this, this was a 90% confidence interval. So we are 90% confident the population proportion is between 0.6111 and 0.6487. Now, does that mean that the true value of the population has to be between those? No, we're 90% confident. That's not a guarantee. So it may not be, but we would expect it to fall in that interval. If I wanted to be more confident, if I wanted to be 95% confident, what would I have to do with those numbers? Yeah, we would have to make a new confidence interval and they would get further apart. If you wanted to be 98% confident, they would get even further apart. The wider they are, the more confident you can be. that your answer falls between them. Yes, ma'am?
Where did you get the 90% from?
That was given in the problem to make a 90% confidence interval. I might ask you about the margin of error, and your error is just this value. So if you just did your 1.645 times that standard deviation, that's your error. In other words, that's what we added or subtracted from our center. Questions there? I've got a couple more things. So a Gallup poll found 54.9% of those surveyed considered the amount of federal income tax they pay to be fair. Gallup reported the following survey methodology. Results are based on telephone interviews with a random sample of 1,016 national adults aged 18 and older. For results based on the total sample of national adults, one can say that with 95% confidence that the maximum margin of sampling error is 4 percentage points. Determine and interpret the confidence interval. So, this was our proportion, right? When you build a confidence interval, you do your proportion minus your margin error and your proportion plus the margin of error. What was our margin of error here?
4 points.
4 percentage points. So that would give me a confidence interval of 0.509 and 0.589. So what this means, we are 95% confident because it was a 95% confidence interval. The population proportion is between 0.509 and 0.589.
Why don't we multiply by the standard deviation?
They'd already calculated the margin of error.
Oh, okay.
So they did all the calculations for us. We just put it in a confidence interval. So let's do another one, building the confidence interval ourselves. A survey asked 800 16 to 17-year-olds in the U.S. if they had ever used their cell phones to text while driving. Of these, 272 indicated they have, obtained a 95% confidence interval. So if we go through our steps, what's the first thing I need? P-hat. That's X over N, so 272 out of 800. What's the second thing we need to do? Check your criteria. Would 800 be less than 5% of the population?
Yeah.
Okay. Second thing, N, so that's 800 times P, 0.34, times 1 minus P, has to be greater than or equal to 10. And that comes out to be 179.52, so we're good there.
So for the point success, you just subtracted the point every 4 miles. Okay.
All right. next thing. We need what? Alright, so our Z alpha over 2. So I want 95% confidence. So remember, that means that 95% falls in the middle. I have 5% to split up over the 2 ends. So how much is on each end? 2.5. So if I'm looking for this one up here, what number am I looking for in the table? So you are looking in the table when your probability is 0.975.
What did you get? 75.
Okay. 95%, since I'm 95% confidence in it, this has to be 0.95. So that leaves me 5% to split up over the 2 ends. So each end is 2.5%. We want this number up here. So if you did, I should say 0.025, shouldn't I? So if you did 1 minus 0.025, that's 0.975. All right. So then that is 1.96. Step 4, what do we need? Margin of error. So we could go ahead and do our upper and lower if you want. So our lower is your point estimate minus your Z times the square root of P times 1 minus P over N, which was 800. And that gives me 0.307. Or 3072 if you did 4 decimal places. On the upper, it's the same thing, you just change it to a plus in the middle. Which is 0.3728. So then, if we want to interpret this, we are 95% confident the proportion is between 0.3072 and 0.3728. So what I'm going to do is I want to increase this from 95% to 99%, but this time I'm going to do it on our calculator. So what you need to do is go to Stat, over to Tests, and then if you go down, you want A. It's a 1 proportion Z interval. So Stat, over to Test, use the right arrow over to Test, and then scroll down until you get to A. 1 proportion Z interval. Okay, it's going to ask us just a few questions. So our X, in this case my X was what? 272. It asked me for my N. What was my 800? it asked me for the C level, that's your confidence level. I want to be 99% this time, so you have to do 0.99. And then you can just hit enter, so it'll calculate. And so it comes out to 0.29686, comma, 0.38314. So this was my lower and my upper.
I might take that, Miss Duckworth. Sorry.
Definitely confidence level with the excellent. Hey.
So what happened to my numbers, my upper and lower limits? Yeah, it stretched out. Those things got farther apart because I increased my confidence level, so my window had to get bigger. So then you could quickly change and calculate any confidence level that I asked you to. Isn't that convenient? Okay, I know we are almost out of time. Can I do one problem out of your book, and then we'll finish this section up tomorrow? Okay. So I want to do one problem like some of your homework questions. So if you would turn to page 431, I want you to look at number 12. Okay, so our directions tell us to determine the point estimate. So we need our p hat. We need the margin of error. And the number of individuals in the sample with the specified characteristic. So we need x. So we are working backwards here. Now, the first question, your p hat, is actually not that difficult to find. I've told you that your p hat is like the center. And to get your confidence interval, you add and subtract your margin of error from that, right? So if you have your upper and lower limits, your p hat has to be right in the middle of those. So how do you find the number in the middle? What do I need to do with those? Yep, add them up, divide by 2. It's just the average. So if we did, my p hat would be 0.201 plus, oh no, sorry, I was looking at number 11. Okay, so 0.051 plus 0.074 divided by 2. And so that is 0.0625. All right, margin of error, that's what you add or subtract to your p hat, right? So if we know p hat and we know the upper and lower bounds, all we have to do is subtract. So I could take like my upper bound minus my p hat. And we get a margin of error of 0.115. You could also do p hat minus your lower bound, and that would also give it 2. All right, the last thing we need is x. Now keep in mind, p hat is just x over n. I know my p hat, and I know my n was 1,120. So if you just multiply that over, we get 70. And so that question really just takes an understanding of what a confidence interval is, knowing that your p hat is the center, you're just adding or subtracting that margin of error. So I am stopping here today. We will finish these notes tomorrow. It won't take me a whole class, maybe the first half of class to wrap it up. Technically, Honestly though, you could probably do everything except maybe the very last homework question if you want to get started. I would recommend at least doing the first few.